Good morning, Year 5. It's Mrs. PA. It's Monday morning. Hopefully you've had a good go at today, arithmetic. I'm going to explain to you how I would go about answering the questions and hopefully providing you with some different strategies that you could potentially use. Hopefully what I explained today will help you with tomorrow's arithmetic, and then on Wednesday I'll do another video which should help you with the rest of the week. But fingers crossed you had a good start to the week with arithmetic. So the first question we've got here is an addition question. When we look at this, we've got a box to fill in here, which lots of you will probably be a little bit annoyed about because you know you're going to have to do the inverse, which means the opposite. So we've got two numbers, okay, that we know. If we add those two numbers to a missing number here, we'll get the answer 33. Now last week I explained to you about the bar model. So this is how I would represent the sum. So I've got three numbers that add together, okay, to make 33. So hopefully what you did, okay, your first job is to think about adding these two numbers together. Okay, because that's something that we know we can work out. We'll worry about this bit in a minute. Now, if you look at these two numbers, they both go into the hundredths. And we remember from last week that we need 100 hundredths to make a whole number. And actually, if you look, you've got 58, add 42 hundredths. If we do 58, add the 2, that would give us 60 hundredths. And then add the 40 would give us the 100 hundredths we're looking for. So we've got 5 and 2 makes 7. And then we've got the 58 hundredths and the 42 hundredths, which gives us another one, which makes 8. Okay, so these two together make 8. So we've got something plus 8 will give us the answer 33. So what you've actually got to do is do 33 subtract 8, and that will give us the answer that we're looking for. So again, this looked like quite a tricky question, but really I've made it so that the addition together is quite simple. Now you could do this in your head. If it was me, I would do 33 take away 3, which would take me back to 30, and then I would take away the extra 5 because 3 and 5 make 8. So 30 take away 5 is 25. However, I'm going to just check my answer very quickly. I can't do 3 take away 8, so I'm going to exchange. Okay, and then make that 30. I'm going to count up, and it is a difference of 5, and then 25. So 25 is the answer for the first one. Okay, if you didn't have a go at this one today, I hope you have a go tomorrow, because now you've got a strategy to use. Okay, now the subtraction this week is all to do with fractions, and lots of people look at fractions and really panic. We have looked at this a little bit in school during arithmetic, so hopefully you gave it a bit of a go. Now, when we have a look, we've got 3 wholes, okay? You need to think about fractions as being whole numbers, okay? And a fraction, when we're using it and we're looking at something like this, we're dividing it into equal parts, okay? So I'm going to represent that sum. We have got 3 wholes, okay? And we're going to take away 2 1/4, and I'm going to see what we are left with. So what I've got to decide is how many parts are each of my wholes divided into. Now hopefully you remember the bottom number in a fraction, we call that the denominator, and hopefully you remember that. The bottom number, the denominator, will tell us how many equal parts each whole is divided into. So what I have done is I have put my 3 wholes, and now I've divided them into quarters, so into 4 parts. All right, so I have got 3, and I'm going to subtract, take away 2 1/4. So what I'm going to do is to mark off what I'm taking. So I'm going to take 2 wholes away. So I'm going to take that away, and I'm going to take that away. So that's the 2 wholes, and I'm going to take 1/4. Okay, 1 part out of a quarter. So those are the parts I've taken away. Now my answer is what I've got left. So I have no wholes left because each whole has got part of it, all of it taken away. I've got 3 parts here left. So my answer will be 3 parts left. And I need to express it as a fraction. So I need to think about, if I had a whole, it would be divided into 4. All right, so I'm looking, I have 3 parts left out of 4. And that's why my answer is 3/4. I can check this by thinking, if I add 2, okay, to these fractions here, I should get the answer 3, which is the number I started with. So if we've got 3/4, add 1/4. So 3/4 add 1/4, that gives us the answer 3. So my answer is right. Okay. Right, now we're looking at multiplication, similarly to last week when we're using short multiplication. So that's when you're multiplying a number by 1 digit. So the only difficulty I've added in this week is we've used a decimal point. Now when you set this out with a decimal point, it's a little bit annoying. When you're multiplying by the bottom number, you don't need to put it in the same place value position. Okay, so if I'm thinking about this 3 as a unit, if we were setting it out as an addition sum or something like that, we would put it over here. But actually with multiplication, we can just put it underneath the last digit. Okay, now I'm going to use Tia as an example, because if we were in school, she would be telling me, Mrs. PA, put your decimal point in before you start. That is the key to this. Then you can just think about these digits as individual digits. You don't need to worry about whether they're worth 100 or 1,000 or anything like that. So we now need to think about 3 multiplied by each of these digits. And so long as we line it up, okay, with our first answer underneath here and then so on, we should get the right answer. So 3 times 3. Now, when I've been setting these this week, I've tried to go with times tables that you can know, or you should know, or you can work out quite quickly. I'm not going to do that forever. That's why it's important to keep learning your times tables. But 3 times 3 is 9. Okay, 3 times 4, or 4 times 3, whichever way round you want to do it, it would just be 3 more than our answer here, because it's 1 more lot of 3. So 9 add 3 is 12. So I'm going to put my 2, and I'm going to carry over my 1 here. It reads as 12. If you carry the 2, it will read as 21, which is the wrong answer. Then we've got 3 multiplied by 1, which is 3, and then the 4 we've got carried underneath. So our answer is 42.9. So just to be clear, the first thing I did was multiply 3 by the 3, and then 3 by the 4, and then 3 by the 1. Okay, so long as I put my decimal point in and I line my numbers up correctly, you should get the right answer. Right, moving swiftly on. I'm trying to do this faster this week because I'm aware that the videos last week were quite long. Okay, we've got 2,500 divided by something equals 500. Now, when you look at this, it might have put you off thinking, well, I don't know my 500 times table. I'm not quite sure how to work with such a big number. However, use what you know to find out something that you don't. So I've divided this number by 100 and I've made it 25. And I've thought, okay, I'm going to divide the answer by 100 as well, okay, and I'm going to make that answer 5. I know 25 divided by 5 equals 5. So there's 5 lots of 5 in 25. So that's the knowledge that I'm going to use to help me work out the part that I don't know. So I'm going to then think, okay, I'm going to make the number I'm dividing by 10 times bigger. So I'm going to get 10 times the amount of 5s out of it. So 250 divided by 5 is 50. And hopefully you can see the connection there, that 2,500 divided by 5 is 500. So our answer for that one is the number 5. Okay, we were dividing by 5. That was the missing part. So again, it's thinking about using something that you know really clearly to work out something that you don't. Again, if you didn't have a go at this one today, hopefully tomorrow's you can have a go at it and get it right, because the question is quite similar. Right, going over to the other side of the board, what we've got this week is 3 numbers added together. So to remind you, I'm thinking about mistakes that are easy to make. So make sure you line the numbers up correctly. Thinking about putting the largest number at the top, that's easier to organise it. Making sure that when you're adding, you're looking for numbers you can add together quickly and efficiently. So looking for pairs of numbers where you know the answer really quickly. Okay, so I'm looking here. So this is how I have set my sum out. I'm very quickly going to make sure my numbers match to the question. Yes, they do. And then I can now solve. So I've got these 3 numbers to add together. Very quickly you can see that 9 and 1 makes 10. That's easy. And then I'm going to add the 2, which makes me 12. Again, it reads as 12. If I've carried the 2, it would read as 21, so it's wrong. So now I'm looking at 5, 2 and 2. I know 2 and 2 is 4. Okay, 4 and the 1 is 5, and now I add the other 5, and it gives me the answer of 10. Now, it doesn't mean you have to add the same numbers together that I have. However, I'm looking for numbers where I'm going to try and cut out any mistakes. I'm looking for numbers that I can add together easily in my head. Okay, I've got 1, 2, 3. I'm going to cross out that, so that makes 3. 3 and 3 is 6. Okay, and then there we go. So the answer is 7,602. Right, subtraction. Again, it's about lining up your digits really carefully, using that decimal point to help you line up. Now, these two numbers have the same amount of digits after the decimal point, so they were quite easy to line up. We don't need to put anything under the 1. You can put a 0 if you want to. It doesn't make that 91.04 worth anymore. If you want the numbers to be exactly the same length, then you can put a 0 there, that's fine. I don't need to do that, I'm quite happy with how it's set out. Right, Tia would tell me again, put that decimal point in, because that will be probably where you make the mistake. Right, remember you have to, when you're subtracting, subtract in the order of the sum. So the biggest number is at the top, and then we're subtracting the smaller number, otherwise we'd be going into negative numbers. So 3, subtract 4. I've got 3, I can't take a bigger number away from it, so I'm going to exchange from the next column up. So I've got 2 there, I'm going to change that to 1, and I'm going to exchange and carry over to the next column. Okay, I've now got 13 take away 4. So I could go back from 13 to 10, that's taking away 3, and take away 1 more, that would give me the 9, or you can count up, whichever way you want to do it. Okay, 1 subtract 0, very easy, is 1. 5 subtract 1 is 4. Okay, we've got 2 subtract 9, we can't do that, so we're going to exchange that 100 and borrow that there and make that a 0, and we're going to move it over to there. So now we've got 12 lots of 10, but because we've lined it up carefully, we don't have to think about it as 120, we can just think about it as 12. So 12 take away 9 is 3. If you know your 3 times table, that would have been quick to work out. So 34.19. Right, moving swiftly on. We're multiplying by 100. Now we remember from last week that each column, look at our number system, is worth 10 times more. Now we know 10 times 10 is 100. So we're going to have to move each digit up 2 columns. Because we're making it 100 times bigger, our number is going to become 100 times bigger. So it's going to move up, it's going to move to the left. Okay, if we were dividing by 10, it would become smaller and move down. So start with whichever digit you want to, that's fine. Remember, you do not rearrange the order of the digits. They must stay in the right order. So either start with the 1 or the 3. So I'm going to move the 1, okay, up 1 column, up 2 columns. Okay, it was worth 100, now it's worth 1 lot of 10,000, so it's worth 10,000. The 2 is going to move up 1, 2 columns. It was worth 2 lots of 10, so 20, now it's worth 2,000. And then the 3 was worth 3 units or 3 ones, it's now worth 300. Now if we wrote 1, 2, 3 as our answer, okay, it would not be correct because it would be the same number we started with. We now need to look at what we've got here. We've got 2 gaps, okay, we need to put placeholders in, but we can't change the size of the number, the value of the number. We can't add anything to it. So if we put a 0 and another 0, our zeros are our placeholders. Now when we look at it, when we are in school, we talk about if you're times it by 10, 100 or 1,000, the amount of zeros gives you a bit of a clue as to how many columns you need to move up or down. So we've moved 2 columns, so we've got 2 placeholders there. Okay, right. Last question, word problem. So we're going to think about our favourite 3 letters, U, D, C. Okay, so I'm going to highlight the parts of this question that are well, I suppose important. So to make 3 identical cakes, I need 660 grams of flour. How much flour would I need to make 1 cake? So 3 identical, okay? Now I put in the word identical because obviously you could make different sizes of cakes, so they would need less or more flour, but these cakes all look exactly the same. Okay, I need 660 grams of flour. And it's asking me how much flour would I need to make 1 cake. Now we're going to worry about the challenge in a minute. All right, so what I can do is draw my 3 cakes here. Okay, I'm going to move that down. And now I've got my 3 cakes. Now altogether, my 3 cakes have, let me have a look, they use 660 grams of flour. Okay, so I'm thinking about 3 numbers that are exactly the same that make 660. Now if we're dividing something into equal parts, we can just divide it by the amount of cakes we've got. So I'm thinking about 660 divided by 3. That will give me 3 identical numbers that will add together to make 660. So then what I'm doing is thinking, okay, I'm going to think about 600 first of all. So 600 divided by 3. So I'm thinking 6 divided by 3 is 2. 60 divided by 3 is 20. So 600 divided by 3 is 200. Now I can use that. So I've done the 600. Now I'm going to do the 60. So that I would use that to help me find out that 60 divided by 3 is 20. Okay, so my answer for this part then, so the answer for the main part is 220, because 660 divided by 3 is 220. So I can now, I'll just write that there for you. It's really hard to draw two, so remember to put in the grams, because it's not 220 bananas, it's 220 grams of flour. Right, how much flour would I need to make 5 cakes? So hopefully what you did was do 200, did that wrong, sorry, times by 5. Now you could set that out as short multiplication, like we did for the question before, or you could times it by 10 and then half it. There's lots of different ways that you could do it. You could double it and then double it again. That would give you 4 lots and then add 220 to it. It's up to you. But I'm going to do 220 multiplied by 5. Okay. 5 times 0. Anything times 0 is 0. If you've got nothing, you times it by a million, you've still got nothing. 5 times 2 is 10. 5 times 2 is 10. There we go. So to make 5 cakes, you would need 1,100 grams of flour. Okay, and if you were trying to be a little bit clever about it, you could tell me that that's 1.1 kilogram. Okay, but 1,100 grams is perfect. Right, don't worry about how you got on today. Hopefully I've given you some tips for tomorrow. And I'll leave another video on Wednesday to explain the next part of arithmetic for this week. But well done.